Hi, so we are here with another topic which is about the Bernoulli's equation. This is also a technique for a first order differential equation in the form written by this dy over dx plus a of x or some function of x multiplied by variable y is equal to b of x y n, wherein our n here is just any number. Okay, so this form here is called Bernoulli equation. Okay, so this form here is the Bernoulli equation. Okay, so last time we've discussed with the also with the first order linear differential equation, right? So last time we've discussed about the first order linear differential equation. Okay, and our standard form for this one is dy over dx plus some function of x, let's call it p of x, y, and then is equal to q of x or some function of x alone here on the right side of the equation. Okay, and if we compare this to, so this equation here I chose the equation that's linear in y, and as we compare this to linear and this Bernoulli's equation here, you can notice that their difference is that the Bernoulli equation is multiplied by this part, the y raised to n, on the right side of the equation, while this linear differential equation here has no y raised to n something here. Okay, so that is their only difference. And if you notice, if this number n is equal to 1, then what will happen in our Bernoulli? It will become a separable equation. Separable. Why? Because if that is equal to 1, then we have dy over dx plus a sub x y is equal to b of x raised to multiplied by y raised to 1. Okay, or just y. Then if you're gonna do the algebra here, we have a dy all over dx plus a sub x y minus b sub x y is equal to 0. And then if we're gonna simplify this, we can factor out y, and then we have a sub x minus b sub x is equal to 0. Okay, then we can now simultaneously multiply dx all over y so that it will now become a separable. So all in all, we have dy all over y plus a sub x minus b sub x dx is equal to 0. Okay, then as you can see, if our n is equal to 1, the equation will become separable. And if n is equal to 0, then what will happen? So let me rewrite our Bernoulli equation here. Plus a sub x y is equal to e sub x y raised to n. And if this n is 0, then y raised to 0 is just 1. So this form here is actually like this topic of the linear differential equation. So this equation here became a linear equation. And also, by the way, if also n is equal to 1, this is 1, this is 1, let me write it. So our equation will become raised to 1, and that is totally a linear equation because we have dy over dx here. The term is linear. A of x multiplied by y is also a linear, and b of x multiplied by variable y is also linear. Thus, this whole equation here do not violate any form which cannot be considered as nonlinear. That's why this equation here is also a linear. Therefore, by the way, this is 1. Therefore, if n is equal to 1 and n is equal to 0, this Bernoulli equation is linear, became linear. Okay. But in this topic, we will concentrate on the case that is n is not equal to 1 and n is not equal to 0. Okay, hence this equation will be considered as nonlinear if we will consider this case. Because why? Because dy over dx is linear, ay multiplied by y is linear. But in this term, since we have y raised to some number that is not equal to 1 and 0, this term now will make our equation a non-linear differential equation, right? So in this topic, we will only consider the case that is not equal to 1 and not equal to 0, okay? Okay. So our technique here, if we have the Bernoulli equation, our technique here is to do something that will make our equation a linear differential equation, and then we will gonna adopt the steps on how to solve the or how to find the solution for the first order linear differential equation. Okay, so on the next video, I will show you the theory or the background behind this Bernoulli's equation, or how can we transform this equation into a linear differential equation. Okay, so see you on our next video.